Hi folks, we're going to take a look at question 20 from page 134. So here they're asking us to find the scalar equation of the plane that has x-intercept A, y-intercept B, and z-intercept C. Okay, so here they're giving this as unknowns. We'll have to work with them that way. First thing to realize is that when they give us the x-intercept of A, that can be translated into a point on the plane. So if it's an x-intercept, it means the y and z components must be 0. So that means a 0, 0 is a point on the plane. Similarly, 0, b, 0 will be a point on the plane, as b is the y-intercept, and 0, 0, c will be the z-intercept. Now we know that if we have 3 points on a plane, we can find an equation. Okay, now in particular we're looking for the scalar equation, so remember that our goal is to find a normal vector, and then we can use any of these 3 points to find the equation. Okay, so the way in which to get the normal vector is to create two direction vectors using these 3 points, and then we can take the cross product to find a normal vector. Okay, so let's call this point A, point B, and point C. So here, first thing I'll do is I'll create the vector AB. Now remember, in the end, especially when we're finding the scalar equation, regardless of how we go about doing it, we should end up with the same answer. Okay, so if we take AB, so we've got 0 minus A, so we've got negative A, B minus 0 is B, and then 0 minus 0 is just 0. Okay, and then we'll take AC. Okay, and if we take AC, we get the vector 0 minus A, so negative A, 0 minus 0, and C minus 0, so C. Okay, so now what we'll do is we'll take the cross product of these two vectors, so we'll take negative A, B, and 0, and we'll cross it with negative A, 0, and C. Okay, so we'll put a negative A and a negative A here. And let's find our normal vector. Okay, so our x component will be BC minus 0. So BC, okay. Here we've got 0 minus negative AC. So that'll just give us AC here. And then for the last one, we've got 0 minus negative AB. So we'll just end up with AB. Okay. Now notice here that, each of these components is missing the one that corresponds to its position. So here we don't have A, which is the x-intercept. Here we don't have B, which is the y-intercept. Here we don't have C, which is the z-intercept. In any case, now we've got our normal vector, and we could pick any of these 3 points. So I might as well pick the first one, A. So again, as usual, we're going to put this AX plus BY plus CZ plus D equals 0. Okay. So here, A, B, and C are going to correspond to our normal vectors. So here we've got BC times, and this, put in our x value from the point that we're using. So we're here times A. And we've got the y component of the normal vector is AC. Okay, oops, and we'll multiply that by the y value of the point, which is just 0. Okay, and then here plus AB. Times the z component of our point, which again is 0, and plus d. And here these just reduce to 0. So we're left with d is equal to negative a, b, c. Okay, so I'll just rearrange here. Okay, now if you think about it, had I used any other point, okay, I would have ended up with the same thing for the z value. Okay, for the d value. So now we can put everything together. So we've got our A is BCX, and then we've got plus, again, always missing that given component, so ACY plus ABZ minus ABC equals 0. And here we go. We have the equation of the plane. Okay, I think we can clean this up a bit, because here, this is ABC, and each of these 3 coefficients contain 2 of those variables. So what I'm going to do is I'm going to divide both sides of the equation by A, B, C. Okay, and it'll just simplify the expression. So on the right-hand side, no problem, it's just 0 divided by that number. Okay, now one thing to keep in mind is if we're doing this, there's an assumption we have to make about A, B, and C. we have to assume that none of them are 0. Otherwise, we wouldn't be able to complete this step. So assuming that we have a, b, and c not equal to 0, we can do this. And what happens here is that when I simplify, so I divide this to each of the terms, well, here the b and c cancel out. So all I'm left with is x over a, and a just happens to be the x-intercept of that plane. Okay, here the a and c cancel out, and I'm just left with b, which is the y-intercept of the plane. And not surprisingly, here the a and b cancel out, so all I'm left with in the denominator is the c value, and then this just reduces to 1. Okay, and there we have it, a much nicer version of this equation of the plane. And this essentially gives us a format that if we know the x, y, and z intercepts of a plane, we can just stick them into this equation. Okay, so if that happens to be the information that's given, you don't even really have to go through all the process of finding your direction vectors, taking the cross product to find the normal vector, etc., etc. If you happen to know this format, since we've shown it completely generally, this gives us the equation directly for the plane with the x-intercept A, y-intercept B, and z-intercept C. Okay, that is it.